Hello everyone, this video is about Chapter 4, Part 2, Binomial Distribution. Binomial random variable is one of the discrete random variables. Binomial distribution is an important probability model that is used when there are two possible outcomes. Here are four conditions for a binomial random variable. First, the experiment consists of n identical trials. 2. There are only two outcomes on each trial. Usually, we call one is success and the other failure. 3. Probability of success stays the same for all trials. 4. The trials are independent. For example, tossing a coin can only have two outcomes, a head or a tail. You toss many times, the probability of a head stays the same, and they will not influence each other, and they are independent. Another example, graduation. There are only two outcomes, graduate or not graduate. You can have many trials, like 20 students. The graduation rate, which we consider graduate as a success, is the same for all the students, and all the student graduation are independent. Also, acceptance is similar, will be binomial distributed. Here is the distribution plot. It looks similar as histogram plot. The x-axis is the number of success, like how many heads or how many students graduate. Y-axis is the corresponding probability of x success. So, in this plot, the height of the bar is the probability. Firstly, let's see the definition. The probability of x successes is shown like this. We use the combination rule here, where n factorial is n times n minus 1 times n minus 2 and up to times 1. In this formula, p is the probability of a success. Q is the component 1 minus p. N is the number of trials, and X is the number of successes in n trials. In our class, instead of using this formula to find the probability, we use binomial table to do so. Now, let me show you how to use the binomial table. In our textbook, the cumulative binomial table is used. However, we recommend you to use the non-cumulative binomial table instead, which is a bit simpler to use. The result of both is the same. Now, let me show you how to use the non-cumulative binomial table. You can download the table on Canvas. N is the number of trials. This is the first number you need to find out. P is the probability of success. X is the number of successes. I will use a real example to show how to use the table. 5 people apply for a job. The acceptance rate is 22%. How likely only 3 people will get the job? First, N will be 5, the number of trial. Next, P is the probability of success. Here, success is accepted for the job. It says the acceptance rate is 22%, which is close to 20%. 0.2. Lock the column of 0.2. Note that you choose the closest number. If P is in the middle, say 25%, you can either choose 20% or 30%. Lastly, find out N. The question asks how likely only 3 people will get the job. So X, the number of successes, is 3. The crossing is 5.1%. So 5.1% of the chance only 3 people will get the job. Now we can use the example and table to figure more cases. How likely more than 3 people will get the job? Again, N is 5. P is 22%, close to 0.2. More than 3 people, it can be 4 and 5 people. So, at the corresponding probability, 0.6% plus 0.0%. The result is 0.6%. 0.6% of the chance that more than 3 people will get the job. Then, how likely less than 2 people will get the job? Again, N is 5 and P is 0.2. Less than 2, X can be 1 and 0. So at the corresponding probability, 32.8% plus 41.0%. The result is 73.8%. 73.8% of the chance that less than 2 people will get the job. Let's do more. How likely no more than 3 people will get the job? No more than 3. X can be 3, 2, 1, 0. So at the corresponding probability, 32.8%, 41%, 20.5%, and 5.1%. The result is 99.4%. 99.4% of the chance no more than 3 people will get the job. One more. How likely at least 2 people will get the job? At least 2. X can be 2, 3, 4, 5. So at the corresponding probability, 20.5% plus 5.1% plus 0.6% plus 0.0%. The result is 26.2%. 26.2% of the chance that at least 2 people will get the job. In conclusion, when you use the non-cumulative binomial table, translate the question into mathematic form, and add the corresponding probability directly. Generally, more than and less than, not including that number. At least and no more than, including that number. Here are some results of binomial table. Mean mu will be n times p, where n is the number of trials and p is the probability of success. It can also be expressed as EX, the expected value. Variance equals N times P times 1 minus P. Standard deviation is the square root of variance. Let's go back to the example. 5 people apply for a job. The acceptance rate is 22%. What is the mean, variance, standard deviation? N is 5 and P is 22%. Mean or expected value is 1.1. That means for any 5 people apply for this job, 1.1 people will get the job on average. The variance is 0.858 and standard deviation is 0.926. Does it satisfy the empirical rule? Let me use falling within 2 standard deviation as an example. Mu and sigma is 0.926. Mu minus and plus 2 times standard deviation is negative 0.752 and 2.952. In this range, x can only be 0, 1, 2. So let's use the binomial table to find out the probability. N is 5. P is 0.2. X can only be 0, 1, 2 as the probability for 0, 1, and 2. The probability is 32.8% plus 41.0% plus 20.5% equals 94.3%, less than 95%. So it does not satisfy the empirical rule falling within 2 standard deviation. That's all for this video.